In this video, we discuss how to perform restoring division. In the restoring division, we want to perform a by 3. So, we want to perform a by 3. We initialize a with 0 and the q with binary form of 7. M value is 3. M value is 3. And we take the 2's complement of m. That is 1101. 2's complement of 3 is 1101. Now we will start the restoring division method. We store zeros, that is we initialize a register with zeros. And in Q, we store the binary value of 7, that is 0111. Selection sequence counter is 4. Since there are 4 bits, the SC is 4, taken as 4. Now perform shift left operation. When we shift this Q bits, and that is the content of the Q bit, we will get this result. After performing shift left operation, perform A minus M. So A minus M means take the 2's complement of 3. M value is 3. So 2's complement of 3 is 1101. Add that with A. If we want to perform A minus M, take the 2's complement of M and add with A. Now we get this result. We add 0 plus 1, 0, 0, 0 plus 1, 1, 0 plus 1, this result. Now we have to see this sign bit. Sign bit is 1. If sign bit is 1, then we have to perform A plus M. When we perform A plus M, we have to add M value with A. M is 3. So add M value with A. So we will get the result as 1 plus 1, 0, carry 1. So again 1 plus 1, 0, carry 1, 1 plus 1, 0, again carry 1, 1 plus 1, 0, leave the carry. So now we had to decrement the sequence counter as 3. Now next step is to perform shift left operation. So these bits are then we shifted. We shift this one to this location. This one will come to this location. This one will come to this location. This 0 will come to this location. We have to put 0 here. So when we perform shift left operation, this is the answer. Now perform A minus M. So A minus M means already I said that we have to add 3. That is 2's complement of 3 with the A content. So now 1 plus 1, 0, carry 1. So we put the 1 here. 0, 1, 0 plus 1, 1, 0 plus 1, 1. So 111, 0. Now again we see the sign bit. Sign bit is 1. Then we have to perform A plus M. That is add M value with A. Now we will get the result as 0 plus 1, 1. 1 plus 1, 0, carry here. 1 plus 1, 0, carry here. 1 plus 1, 0. We will omit the carry in this case. Always here we will omit the carry. Then, so this is the result we are getting. So if this result and this result are same, then we are right. Here note that this result and this result are same. So till now we are going in right direction. We are getting the correct answer. The next step is to perform. See here, next step is to perform shift left operation. So when as usual, when we shift the content, Q content, we will get this result. So now next step is A minus M. So add the 2's complement of M with A. So when we add this, we will get this result. Okay. So we will always omit the carry. So we get this result here. So now since the sign bit is 0, we will not perform A plus M. So now what we have to do is, we will take this value, and since this bit is 0, this 0 will be replaced with 1. So we will get this value 1001. The next step is as usual perform shift left. So we will get this result. When we shift left this, then we get the answer and this answer. Now again perform a minus m. That is add the 2's complement of m value with a. We get 1110 as the result. Again when we see the sign bit is 1. So now what we have to do, again we have to add a plus m. That is we have to perform a plus m. When we perform a plus m, we will get this result. Now we have to decrement the sequence counter, that is 0. And since we have the sequence counter has become 0, we have to stop the operation now. So we get the quotient as 2, remainder as 1. So our division is right. That's all about restoring division. Thank you.